name, or still some of you have not yet created? Guys, can you hear me? I have created. Yes, I can. Okay. Okay. So I think last time you set up your domain name in, like, I think you have set up a DNS in your system. So now is it working? Okay, perfect. What about Rahul and Sumit? Not yet working on it. Okay. Okay, guys. So actually, tomorrow I have to start another training for Kubernetes infrastructure. So I was just preparing some document, and I found very good resources here. Learn Kubernetes in Node.js Kubernetes guide. So explanation is really good. So if you guys are really interested in, I can share you this one. Otherwise, but I think you guys should do this lab, because they have very good informations, each and every, like graphics and all. They are really nice. So I think we should do this lab as well. Means here they have given the flow like this one, how you can convert a traditional app like simple Node.js application to Docker container, and then Docker container to Kubernetes infrastructure. So they have explained each and everything, conversion and all. If you want, then we can today like cover this topics. What do you think, guys? Yeah, this is the link. Okay, so no problem. So what we'll do here, we'll do this lab for today's, and we'll explore like one each and everything one by one, because I think this will give the very good idea. Means like how to design a simple applications. Okay, so let me do one thing. Uh, yes. Yes. So guys, see, idea is like uh, we have a very simple Node.js and MongoDB application. So guys, you'll have to understand one thing. The life cycle of pod is limited to when you are creating your pod and when you are destroying your pod. So this is the life cycle of any pod, but this should not be the same for your database, because whenever you are working with the database, at that time what should happen, if your instance will be deleted, so what should happen, your data set, whatever the data you had in your database, it should remain with you. Means it's not like it should destroy your database again. So this is what like they have explained it here. Means in simple, like we have a very normal application, Node.js application, and with Node.js application we have this one, like you can say we have very this one like MongoDB connected, and MongoDB connected to be persistent. Persistent means your database should not destroy once you once you this one, once you um, delete your infrastructure. Data should be still, it should be available in your at your some volumes. This is what we are going to do the same. So this is just a UI that we are going to cover. Let me cover it. So in the meantime, I'll also prepare this document, because this URL may be this one. It may or may not be available, but we should have some document, and I'll try to keep very simple document so that it will be good for you guys for your later use case. So guys, you got an idea how it would work? So simply, what we'll have to do, we'll have to copy this one, clone this. I just created this one. Okay, let me go to this link. So somehow like 1 2 3 4 5 6 around they have created this one, 2 3 4 5. So I don't know like whether we need to go for this one or not. But anyway, what we are going to do here. So guys, just open this link and we'll follow one by one. Okay, node. Okay, 01. Okay, so this is the very application, very normal application that has been created. Uh, Let me open it in the files as well. Yeah. Do you want to say something, guys? Okay. So guys, this is what we are going to do it here. We have very basic application. Okay, and we have data MongoDB database. Name of this application. That's it. MongoDB. So guys, it is a combination of our Node.js and MongoDB application. Okay, so let's do it one by one. The way it has been written, we will follow the same. remove this one. Okay, this is what we have done. Now we'll have to go inside this one and we'll have to use node and this one. So let's say if I use npm install. So this is just a very basic Node.js application. Now if I run like this one, node index.js, so what should happen? Our application should run on port 3000. Let's run this one, localhost. See here, our application is running. If I upload some files, let me see what happened, like why it is showing. This file gone. Okay, this is how it would work. Let's say hello image. Now if I publish, perfect. Can you see? This is how it is working with image with this text. This is what the application is. As of now, it is running on a very nominal application. Okay, now what we have to do here, let me stack express. Okay, I think this one is not required because this is of no use in your case. So I'll shorten this thing so that okay. So MongoDB, of course, guys, if you remember, if you want to understand what exactly MongoDB is similar to MySQL or this one, but MySQL is a SQL database. MongoDB is no SQL database. Means you can store your unstructured data as well in case of MongoDB. So this is what they are trying to say. So this one is not required in your case. Okay, now, so what happened, like what we have done, we have right now what is happening, our application is running on port 3000, and see, it is working perfectly fine in our local computer. I need to convert this application into Docker container. So as we have already learned earlier, what exactly we are going to do, uh, in order to connect, means uh, in order to do this one, the step is very simple. We may have to create a we may have to create Docker file like this one. We may have to correct Docker file like this. So we'll go to Docker file. Okay, let me exit from here. Okay, touch. Okay, and inside this one, I'll put all this code from here. Okay, so again, same thing. If you see here, earlier we run our application using Node and index.js. If you remember, like we have already discussed, whatever the CMD you are writing here, when you create a Docker container, when you run a Docker container, it will go inside and it will run it in the background. This is what it is happening. So the step would be very simple. So they have already explained it here. From means the layer in case of version, ever node install, cp copy command, np install. They are very simple, and at the end simply run this command. So this would create a K-node application. Run this one. Okay, so our Node.js has been created. So what we have to do here? They have defined like this one image layer. Obviously, if you play it one, node copy run npm install. This is how the layer has been built, and this is a Docker file, Docker image, and Docker container. So you can create from one Docker file, you can create one Docker image, and from one Docker image, you can create multiple Docker containers. This is what they have told us. Okay, now if you to so no, as we need to use Docker means MongoDB in order to work with this Docker container. So that means Node.js should be MongoDB should be also installed in Docker container. So the step would be okay. Now coming to the point, as we have already discussed earlier, if you want to create two different Docker container, and if you want to make sure like both containers are talking to each other or maybe connecting to each other, in that case we may have to create a bridge, network bridge. If you remember, like we have already discussed, let's say I'll tell you like what exactly I'm trying to say. Yeah, this is the Docker tips. Without Docker container. So if you remember, we have discussed two things: with Docker container, without Docker container. So sorry, without Docker Compose. Without Docker Compose, what was the configuration? We had to create a bridge between both. Bridge was like this one. Either we will have to connect these things. Oh, sorry. We had to connect here like this one, link like this one, or with Docker, we had created a kind of bridge. So what was the bridge? First, we created our this one network. Let me show you the code. So what is happening? Network. So this is the network. Using this network, both application were communicating to each other. You can see network is equal to Node.js net. In Nginx also we have provided the same. In application we have also provided the same. Same thing. If you want to, either you can use link method or you can use network. If you want to connect this kind of infrastructure. Okay, so this time we will be selecting link method. So for that, first you have to create a link called knode, or that would be a network. So but see here, see here, that knode and Mongo container should communicate to each other, but they can do only if they have the same Docker network. See here. So create a Docker network for means in other network they cannot communicate to each other. So we have created a Docker network. Now if I run this one, so what will happen? It would run our Docker container, and with the game name we can provide like this one. By the way, guys, anyone can explain me what do you mean by this one RM? Anyone can explain me why we are using if I use minus RM, so what will happen? Yeah, I know, but why it is error? You cannot find the model. So Ashok, have you this step npm install? Have you performed this step? I that step, but it was showing that one. But why it is not showing? In our case, it was running. Can you see this screen? It was running earlier properly. Ashok, is it working now? Let me say. Let me show me. Let me share your screen. Can you share me your screen? Okay. So what kind of message you're getting? Okay. Are you into this one? Like RSCD one? Okay. Can you just install npm install?
You are now unmuted.
Can you do it again? Can you do it again? npm install. Oh no. See, hold on. Uh, why you are using sudo in case of you are into this project? So you should not sudo. If you are using sudo, then definitely your computer is not configured properly. Sudo means you will install this application in your this one means you'll have to install it in your global, but you'll have to install locally, not globally. Now can you run it? Yeah, but yeah, that's it, because you should not use sudo in that case. Okay. Fine. Okay, so now what we have done, we have already added this one and finished. Okay, sorry, we were into this location. Docker images. Okay, run means what will happen? See, automatically clean up container and remove the file system when the container exit. Means when you stop your container, so what does it happen? It should also remove whatever the garbage file you have added. It would remove. Got my point, guys? Why we are using RM here? Means when the data and all the life of data will be as your Docker container exists. If you remove your Docker container, it will remove that that garbage as well. That's why we are using RM. Oh, sorry, I have not shared the screen. My okay. Yeah, so in your case, I think you might have not I think your MongoDB is not available in your computer. That's why you are getting this error. So no problem. We'll be see the idea behind this lab was, I found it is very interesting. So it gave us the idea like how you can transform a simple application to Docker container and then Docker container to Kubernetes
You are now
infrastructure.
muted.
So this is
You are
the
now
life cycle they
unmuted.
have provided they have provided. Okay, so this is what they are going to. So right now, what is the way you are doing right now? You are doing it in your local computer. So in that case, your MongoDB should be available in your case, but it is not available. That's why it is showing an error. So now next step would be we need to run this application in our Docker container environment. So now we are doing the next step. So what happened? Like I was doing. See here, our MongoDB is running. Can you see? uh, it is running in the background. Now I can validate as well. Docker ps minus a. See here, our it is running. It is running on 27027. Let me delete that one. Docker rm. This one. Okay, so you can see here. Now I have Docker ps minus a. Only one Docker container Node.js is running. If I exit Docker top 8c. Okay, now if I remove a Docker rm, what will happen? It will remove no Docker container. Okay, can you see? See the advantage of this one. What happened? I simply stop this Docker container. Just by stopping this one, Docker container was not available. So you can imagine now this one. Let's say if I created our Docker container like this one, let me show you this. Okay, so this is the step. Like what happened, I did Docker run name mongo dash dash rm network is equal to this and more. So what will happen when you stop your Docker container? What will happen? All the data, whatever the data you have Docker container, it will remove by themselves. You means you need not to remove your Docker container by yourself. It will be done by themselves. So like this one, as of now, our Docker container are available. You can validate as well. But if I, even though if I'm not removing it, if I simply stop like this one, Docker stop one app. Now if I find this one, see, no Docker container are available. Reason behind it, we had selected this option, RM option. Now you understood why we are using RM here. The main reason behind using RM here, because we are just testing this one. We are not actually doing this kind of production kind of stuff.
You are now
That's
muted.
why we are using this one. So let me do it again because I may need it in case of this application. See here, automatically clean up the container. Remember when the file container exists. Network means represent Docker in which the container should run. When omitted, container should run by default network. Mongo name, obviously we want to run as a this database as a Mongo. That's why we have given the name is equal to Mongo like this. Okay, now what we have to do here, if you see this file, can you see Mongo URL? So this means process.env.name. So what will happen? They will try to find whether MongoDB URL exists in the environment exists or not. If not, then they will go for this URL. Okay. So what will happen? In our case, what we are going to do here, we will be passing this information: Docker run kno knode network internal port is equal to 3000, external port is 3000, and URL would be Mongo is equal to MongoDB. Here, see here, MongoDB is the base, and Mongo. This is the name of your Docker container in which your Mongo is running. See here, this is the name. And port by default it is running on a port 27017. You can validate it as well. See here, it is running on 27017. This is the same. So if you run this one, so what will happen? It will create a Docker containers. Okay, so I may have to remove this one, Docker es minus a. Docker rm q3 lsof minus I 3000. Okay, so this was the creating problem because they were not port. This PID was still existing. L minus 9 7430. Perfect. Now you can see our application is running. Again, if I go to here, see it is working. So now this time our application is running on Node.js. Obviously Node.js and as a front end, and MongoDB as a backend in Docker container itself. You can validate it as well. I will validate it. You can get this information like this one. So right now it is on this timeline. Okay. If I upload image, what will happen? State will change. Can you see? Can you see it about this one? Now after that, what happened? This image has been created, and this status has give this information. Is that clear, guys? So far, is that clear to you? Ashok, is that clear? Okay, now this is the same thing. Automatically clean up the container. Network representative same. Environment variables means if you want to pass some extra environment variable in Docker container, you'll have to write like this on -c, and so now you can also mean this is the same thing that I have available. So simply you can means if you want to use this one, simply you will have to use this one. What is happening? Why exit is not possible? So, I may have to close this browser only because exiting not possible. I may have to close this terminal. Docker ps -a docker top ab 8d. You can see both images has been removed. Okay, so now what we have to do here, uploading Docker image to Docker registry. Not means we have already learned this stuff earlier. Means the step will be very simple. Docker login, and after that you will have to put your username, and you'll have to put like this one, and it would work version. So we are not going to discuss this thing here again, and this is the same thing that we did earlier. Now deploying at a scale means we can use elastic beanstalk and all, but we'll be using this Kubernetes infrastructure. Okay, guys. So so far we have what we have done. We have simply run our application. We tested it locally using Docker container, and it was working perfectly fine. Now we need to deploy it into our Docker Kubernetes infrastructure. So for that, we may have to use multiple methods that are available. Uh, uh, so guys, this time we will be using Minikube. Guys, you know how to install Minikube in your local computer? Uh, Minikube in MacBook. Let's say I'll install it in my MacBook. The steps are very simple. We'll be following any one of them. Okay. Sorry. In my case, I have already installed this one, Docker. So Kubernetes is by default it is available.
You
So
are
I'll
now
be using this
unmuted.
one, Docker for desktop. Uh, Minikube is it is similar to Kubernetes infrastructure what we did in cloud, but you can similar kind of infrastructure you can do it in your local computer as well. So, but in my case, I think there is some problem with my computer because
You are now muted.
my storage is very limited. So I mean, it may not work in our case. See here, I have just 8.86 GB available. So it won't be a good idea to run our this cluster in case of this one. So I may have to use this one only means like AWS kind of stuff only. So let me select AWS containers, AWS. Mm, okay, guys. Now you have two options. Either okay, not Virginia. Why this instance has been deleted? Okay. Oh, okay. Sorry, my instance is stop condition. So I'll be starting this one. Start instance. Okay. So what I'll do, I'll start my EC2 instance as I have already configured each and everything. So just I need to run a very basic command and it will start work. Let me connect. So what I'm doing here, in the last classes, what we have already created this cluster. Means we have already created this cluster here. So we will be continuing this one. Already these are available. Let me go to my GitHub, github.com. Okay, cops. In order to spin up our cluster, step was very simple. Means see what happened. I have recently restarted my server. So like all the steps that we have already done earlier. So what exactly we'll have to do? We'll have to do this one default. This part is already done. Node count. This one domain. So here I'll have to change the domain name and bucket name. That's it. So and we'll simply run this step and it would work. Just a minute, guys. Hello, Amol. Uh-huh. Okay, so I was trying to say, if you see this here, if our cluster was created earlier, so simply we'll have to run this command, and whatever the export command that we'll have, it will be done in one go. So let me edit this file, cd kubernetes cd script, and what I'll do, nano port dot this one, and here I'll have to change the our domain name. So domain name was it was KANTLEARNINT learning.com. KANTLE, yeah, fine. And the bucket name, what the bucket name that I'll have to create? I'll have to add the bucket name that are available. Let me verify it. I think I'll be using this bucket name. That was the good options. So simply I'll put it here and this. So what will happen? It would run in the bash port. What happened? Weird. Oh, sorry. I'll have to run it here. Uh, bash, and Kubernetes dot script and dot export dot ls. Perfect. So now if I in order to understand whether it is working or not, so what I'll do here, I'll check whether our data is already reflected or not. So we'll use this one, bucket name. See what kind of bucket name I have, right? Echo dollar sign, this one. Oh, so it is not showing. I think I may have to do like this one. Permission denied. Okay. Uh, it is not showing. Okay, no problem. So I'll do it manually. I'll do it later. But for now, what I'll do, I'll simply run this command, and I'll run it one here. Oh, not from here. I need to do it from. Perfect. Now if I see our bucket name, perfect. So it is working now. Now let me do one thing. Initialize. In order to initialize the command, again it has been created. Perfect. So I'll run this again. That's it. Perfect. So now this is working. So what will happen? it will start a cluster within few seconds. Oh, sorry, few minutes. It might take 10 to 15 minutes, and each and everything will be done. So guys, are you comfortable with this script, the way script I have created, or do you think still you have some confusion? Okay, so once the cluster started, so in the meantime, I'll start working with this file. CD cube, and here. So we'll create a file called keynote.yml file, means for our application. Okay, so guys, you'll have to understand one thing. Here, image need to be added like this one. Let me show you like this one. Why we need to have like this one? Can you see? This is they're showing like I need to deploy this application on their node, or else we can use our local node here. So I'll prefer to use local one. Why? That the things I'll tell you like this one. Initial this, like let's say I'll use this one. Prabhat. Okay, and I already have this Docker container, Docker ps -a, Docker images. Uh, this one is Keynote. Yeah, Keynote is available. So what I'll do, I'll simply push this Docker image into server. So what I'll do, Keynote like this one, and Okay, fine. So this is what we are going to put it like this one. So the step would be very simple. Docker login. Perfect. So our login successful. Docker. And guys, can you tell me what is the tag for this one? If I need to tag our Docker container, what is the command?
You are now unmuted.
Simple Docker tag or something different? Exactly. See, Docker tag
You are
name
now
and
muted.
so this is the format that you will have to follow. Username and password. So in our case, I am using this one, and here I am using my username. Prabhat. So this is what my Docker username is. Prabhat. Docker tag name of the name of the Docker image that are exist in our local computer. If I do so, what will happen? Now Docker ps Docker images. See, this one is available now. So what I'll have to do? I'll have to push it into the server, into Docker Hub. The step would be very simple. Docker push, fine. Oh, so why it is showing like this one? Docker push Prabhat, no. Okay, anyway. Perfect. So I think server is already spin up. Only is, yeah, perfect. So in the meantime, our server is also spinned up. So let's do it. What I have done so far, I have added this Docker. Okay. So guys, step is very simple. The way we did it earlier. So first step is our application, then kind, then metadata, then replicas, selector, template, SPC, container, environment, and this one. So this is just a definitions. Okay, now let's do it from here. You know how? So first line of the documentation where that. Uh, okay, let's see if you if you run this one, it so it would give the idea. See here, this is how they are giving number of desired port. This is the pointer to distinguish between explicit 0 and not as by default is 1. Means replicas means it will give the idea how many replicas. So it is similar to like the help file that we learned earlier. So if I run this one, Doctor explain deployment. See how it will give the idea. See here, this is what the information you will be getting. Kind. So they will give you each and everything from here. If you think dot spec spec here, they will give the all the available options. So technically, guys, like if even though if you don't know how to write this YML file and all, using this command, you will be able to get each and everything information from here. So next is that number of replicas is equal to 1. What is the pod? Uh, Pod is the vapor around the one or more containers that we have already discussed earlier. So you can see selectors. Selector means the name of your application would be K-node and the label of this one is equal to this one, like this one. So what will happen? The template meta field define the label of the port that WAP your node application. Selector meta field that port are app node, their label belongs to the development resource. After that, you may have to provide the container information. And if you have some kind of environment variable, that you will have to define it here. Okay, so now in order to run your deployment, you in order to access your deployment, you need to have the services that we discussed earlier. So here we are going to, so service is like this one. Incoming traffic, if you have multiple port, so how this port should communicate to each other, or this one. So this is what they have given this information like this. Port 1, port 2. So you may have to create services as well. So what I'll do, I'll put this information inside this file only. And like if you want to use the same file here, you will have to write some kind of dash kind of stuff. There was some dash, or they have to go to I think this is where we have put that was in the chat application. Okay, if I'm not remember, that was the chat application, and in that case we had service and deployment together. Yeah, like this. Oh, simple. Okay, simple dash would be fine. I forgot to write double. This simple dash would be fine. Deployment. Okay, 3 dot. Sorry, 3 dot, 3 dot. Fine. See here, you should always depend with three dash, not more than that one. Otherwise, it will start throwing an error. So this is what our deployment was. This is what our services was. Guys, Docker. So guys, are you understanding or not? Things what we are doing right now, are you able to understand or not? So here you can say in the service part, we have multiple stuff. Selector is equal to app K-node. So this one should match with your application deployment name. See, this is the deployment name. This one should match with this one. Then only it will create service for this one. So you can see here, selector this one. In this case, all the port have label is equal to this one. App is equal to no K-node. App is equal to K-node. See here. App is equal to K-node. So what will happen if you are selecting this one, selector is equal to this one, so they will check using this one, and if both are matching, So what will happen? See, selector and template, sorry, template using this method means if you are having app label is equal to node and here this one. So what will happen? Both will talk to each other using this method. Selector is equal to this one, select a template is equal to this one. This one would help in case of replica. Let's say if you want to make 1 to 3, in that case this one help you, in your case this one. So this will increase the means you can say this selector mesh level will help in case of your internal number of app, and here it would help us in case of externally. Means if you want to create service for this application, they will go inside this one and they will check by what name it is available. If it is available with this one, then uh, it will create the services for this name only. So guys, is that clear? Vijendra, are you understanding, or it is going overhead? It's like little complicated. Why? See, you may not necessity to remember each and everything. Just take the one very small a small sample like this one. This terminology, like it's very simple, like deployment, app, v1 and all. You may not have to remember each and everything again and again. Simply just check the reference and this one. So you can see, if you see this deployment and this one, both are same. Just you need to change this name here like this one. If you want to create a multiple replicas, simply change the name. If you want to create services, this one which should match with selector. This SPC containers means you will have to define the name is equal to app, what's the reference, image, internal port number, like this one. So this is how you'll have to define each and everything one by one. And see here, target port is equal to this one, and your container port is equal to 80, and at the end what we are defining here, type is equal to load balancers. What will happen? It will create a load balancer for you, and it will deploy your application here. So this is how it is working. Port this one, port 80, internally both would communicate to each other. Okay, now here this is the important concept, deploying a database layer. Database layer can be deployed the same way as this one. However, deploying MongoDB needs some additional configuration. MongoDB requires persistent storage. Thus, storage must not affected whether it happened MongoDB port or not. If the port is deleted, storage must persist. If the MongoDB port move in another node, the storage must persist. So this is what this is the concept for persistent volume claim. So this is from where we are going to create some kind of a space for the same. Means in order to make your database persistence, you will have to write some logic. So let me write it from here. So what I have done, v1 persistent, and see the name. See, this one is really little difficult, but you will have to understand. It is very simple, by the way, and the type is very simple. So API version is equal to v1, kind is equal to persistent volume claim. name is equal to Mongo dash PVC version volume claim. Access model is equal to read write once, means at a time only one pod will write to this one. Storage, what we are defining, 256 MB we have defined. In order to access your MongoDB, we need to have services. So service is equal to this one, API web service port. Internal port is equal to 270017, external port is equal to 27017. Okay, now deployment. Here, as we will be using deployment and the Mongo, means we do not have the our own custom image, rather we will be using a extended docker containers. So image will be simple Mongo. So it will select a latest one, and see here, this one is very important. Volume mount is equal to storage, and the part will be db data.db. So here you will have to define this volume. Name is called, so this one volume mount and this one both should be claim, both should be same. And see here, persistent volume claim, what we have defined, we have defined in here. So that means this name and this name should be same, and claim name is equal to Mongo PBC. So it is something little confusing and all, but trust me, this structure is very remains same. Means once you learn for one project, you can apply it for any project like this one. This is what I have explained it here. So I just define each and everything in the single application only. Okay, let me write it here, and make dir kno keynote td keynote. Okay, touch, and I'll write name like this one only, keynote.yml file, knote dot yml, nano keynote.yml file. I'll paste it here, and I'll write kubectl create -f keynote.ca. Perfect. So this one has been created. You can verify it from here as well. kubectl get all. Perfect. So it is being created. Container creating. Mongo is in progress. You can see it here. They are still into container creating phase. It might take some time to deploy this stuff. If you want to see what is happening inside, you can go. You can also visit this one. See here. Docker, sorry, kubectl describe this one. So it would give the idea. See here, created container, started container Mongo. Let me see if still it is giving the same error or not. Perfect. See, it is started running. This is our load balancer is now, depending upon your this one. So I think it might take some time. So let me see if our cluster is running, or our node, the IP address, elastic IP address, load balancer IP address, I would say. See if it is in the provisioning stage or not. Okay, so by default, classic load balancer, it should be NLP. Okay, anyway, the way it has been created is it is creating NLP load balancer. So what should happen? After some time, it should start by themselves. I'll check in service. Unhealthy threshold, healthy threshold, listener. So by default, if you are not selecting, it is screening classical. But if you are providing the information like the way we did it earlier, see here. If you divide like this one, so what will happen? It would create NLP type of load balancer. Otherwise, see here, what happened by what we have defined? We have simply defined our load balancer need to be. That's it. This is what we have defined. If you want to be specific more into this one, we can select this one. Annotation is equal to this one. So what will happen? It would create NLP instead of this one. Can you compare it here? Means you may have to define inside metadata. Inside meta, this is what our metadata is. If you define like this one, so what will happen? Instead of classic load balancer, it will create info load balancer. In the SPC, we have to define. So guys, did you understand this concept? How this one is working? How you can define network load balancer and classic load balancer? Perfect. See here, same application is running. Perfect. It is running perfectly fine. Guys, did you understand the logic behind it? How it worked? Uh, Vijendra, Rahul, Ashok. Okay, so guys, this one is really nice. What I'll do, I'll try to update this file in my version. Right, I have already started this one. So what I'll do, I'll convert this this lab into my version and then I'll update it, because uh, here in this lab they have selected like this one Minikube. Instead, I'll use cops and will combine the same. This way, it would give the proper idea about the same, how it is working. So in order to remove the clusters, the step is very simple. I'll simply go to here and steps, delete cluster. If I do so, whatever will happen, cluster would be deleted. Okay, guys, I request you please go through this file again and try to understand this one, how it has been created, and they have explained each and everything very well manner. Means even though if you do not read official document, you will be able to understand each and everything from here. So read it and it will give you the good insight about this. Okay, guys, then see you in the next class.